The aim of this PowerPoint is for you to complete a past paper question. The PowerPoint is scaffolded into 3 sections so that you can choose how much support you think you need. First of all, you look at the green section where you'll be given the past paper question and you should press pause and have a go at it on your own. If you manage to get to an answer, then the mark scheme's at the end of the PowerPoint so you can check to see if you've got it correct. If, however, you're struggling with the question, you may then want to go on to the amber section, section 2. In this section, I'll go through a few hints to hopefully help you to get started. You'll then press pause and have another go at the question using the hints and tips that I've given you. If you manage to get through the question, then again you can check it from the mark scheme. If at this point you're still struggling with the question, you can then move on to the red section, section 3. This is where I'll model how to answer the question from start to finish.
Here's an exam question on the modulus function. Press pause now and have a go at it on your own first. Then if you get stuck, watch the next slide where I'm going to give some hints and help. If you're watching this part of the video, then it should mean that you've tried the question on your own first and maybe you need some help. So here are some hints for question A. There are a few different methods of doing this. One method would be to square both sides. So if you're happy to go with that, I would just square both sides and then solve the quadratic. As an alternative, if the modulus of something is greater than 7, imagine where that would lie on a number line. Numbers that are greater than 7 can be found here, but modulus means ignore the minus sign and look at just the number part itself. So if we went here on the number line to numbers like -8, -9, -10, the modulus of those is also greater than 7. So what you could do is split this problem up into 2 parts and say that 1 minus 3x needs to be greater than 7, and you could solve that, or 1 minus 3x needs to be less than -7, and you could solve that. And that would give you 2 answers, just like the other method I mentioned, which was to square both sides. That would give you 2 answers as well because it would be quadratic. For question B, if it was me sketching this graph, I would start off by just sketching y equals 1 minus 3x. Then after doing that, I would change that into y equals the modulus of 1 minus 3x. And then once I had that drawn, then I would move it down 7 to make it the modulus of 1 minus 3x take away 7. Press pause now and have another go at the question. If you're still stuck, then watch the next part of the video. So now I'm going to go through the question in detail in case you were stuck. When we're solving the inequality in part A, if the modulus of something is greater than 7, that means that 1 minus 3x is either greater than 7 or 1 minus 3x is less than -7. And now I'm going to solve those 2 inequalities. You could start by taking 1 off both sides, so minus 3x would be greater than 6, and then you could divide both sides by -3. Don't forget that when you divide by a negative number, you have to flip the inequality around. So this will become x is less than -2. Similarly then, for the other inequality, if I take 1 from both sides, then -3x would be less than -8. And now, because I'm going to divide by -3, that flips the symbol around. I'm going to leave this one as a fraction. For question B, let's start off by just drawing y equals 1 minus 3x. So this is a nice simple linear graph. It's got a y-intercept of 1 and a gradient of -3. So it would look something like this. I think it would be helpful to find where it hits the x-axis, and to find where any graph meets the x-axis, you just put y as 0. So if we put 0 equal to 1 minus 3x and solve it, x is going to equal 1/3. Next, I'm going to draw the graph of y equals the modulus of 1 minus 3x. Now what we need to do here is bounce any parts that were below the x-axis up so that they are above the x-axis. so the graph is going to turn into a V shape. It will still hit a third on the x-axis and it will still go through 1 on the y-axis, but the part that used to be under the x-axis has been reflected up. Now finally I'm ready to do the modulus of 1 minus 3x take away 7. This just means that I need to slide my previous graph down 7. So it's going to look something like this. The minimum point will still have an x-coordinate of a third, but this time the graph will hit the x-axis at -6 because it used to hit at 1 and we're taking away 7, which takes us down to -6. Finally then, the question asks us to label where the graph crosses the x-axis. With this equation here, if we brought it all over to one side, so the modulus of 1 minus 3x, if I took the -7 over to the other side, equal to 7, you can see that this is very similar to the inequality that we solved in part A. So actually the numbers where the graph hits the x-axis are the numbers that we found in part A. So we'll have -2 here and 8/3 there. Here's the mark scheme for that question.